Hello, everyone. My name is Seth, and this is Acquired Salary. Today, I'm going to be going over everything you need to know about biology and biomedical science degrees. So, if you're wondering what degree you need for biology, what you can do with a biology degree, or what jobs you can get with a biology degree, stick around. I'm going to discuss industry size, growth, including unemployment rate, average salary, typical education pathway, and typical jobs and career trajectories. If you appreciate information like this, please drop a like on the video and subscribe to the channel because support like this goes a long way and I plan to cover every major industry. Before we get into it, when discussing industry growth rates here, the breakdown is following the Bureau of Labor Statistics and how they define industry growth. So, much faster than average is going to be 9% or more. Faster than average is 6 to 8%. As fast as average is 3 to 5%. Lower than average is 1 to 2%. Little or no change is less than 1%. And decline is obviously anything that is going to be less than 1% or to kick things off, though, we're going to get into the overview of these degrees, kind of what they do, and then we're going to get into the specific details. So, when it comes to biological and biomedical sciences, we have biology or biological science degrees. These are going to be degrees studying living organisms and their vital processes. Then you've got biochemistry, which is the exploration of chemical processes within and related to living organisms. Then we have microbiology, the study of microorganisms, including bacteria, viruses, fungi, and protozoa. Then we have neuroscience, which is the scientific study of the nervous system, and genetics, which is study of genes, genetic variation, and heredity in living organisms. The first degree that we're going to take a look at is going to be biology. So, when it comes to industry size here, the life science industry employs about 1.5 million workers, and this includes about 100,000 biological scientists. Related sectors like healthcare and biotech employ millions more. Growth rate here is about 7% by 2032. This is going to be driven by research and healthcare demands. The average salary is about $82,000 per year. Entry-level lab technicians can earn about $50,000 per year, and PhD level researchers or professors earn $100,000 to $150,000 per year. The average unemployment rate is 3.8% for biology degree holders, specifically bachelor degrees holders, and this gets lowered to about 1.5% for those with graduate degrees due to the specialization of those roles. The typical education pathway is going to be a bachelor's in biology. This will take about 4 years. You can then get a master's, which would take about 2 years, or you can pursue a PhD, which is anywhere from 5 to 7 years. And if you're going for a PhD, you're likely going to be focusing on research, academia, or other advanced roles. There are many different routes with biology degrees, but this is often a degree selected for people that are pre-med or pre-vet with tracks to professional schools. And then when it comes to job placement, internships or lab experience are going to be critical. The typical career trajectory is going to start out somewhere around a lab technician or a research assistant. You can then become a biological scientist or a clinical research coordinator. And then you can get promoted to a senior scientist, professor, or a medical professional. But medical professionals require further education. Again, many people in biology degree programs are pursuing medical degrees, dental, or veterinarian school. Next up, we have biochemistry. Biochemists and biophysicists number about 35,000, and this is going to be within the broader biotech and pharmaceutical industries, which can employ around 500,000 in this specific niche. Growth is projected to be about 7%, and this is going to be fueled by drug development and medical research. The average salary is about $103,000 or $104,000 per year. Entry-level roles start around $60,000 per year. Senior researchers or industry scientists earn over $130,000 per year. The average unemployment rate is about 3.5% for biochemistry bachelor degree holders. And then PhD holders face lower rates at about 1.2%, and this is due to the demand for their advanced skills. The typical education pathway is going to be a bachelor's in biochemistry. This would be about 4 years. To really have the job security, you're going to want a PhD or a master's. Master's would take about 2 years, PhDs anywhere from 5 to 7 years. And it is, again, very standard for research or academic roles. And when it comes to job security, having lab experience or getting your first job out of college, lab experience, again, is very essential. The typical career trajectory is going to start out somewhere along the lines of a research technician or a quality control analyst. Then you can get promoted to a full-blown biochemist or research scientist. You can also be a toxicologist. This is what I did previously. And then you get promoted to a senior scientist or an R&D manager. Again, some pursue this degree with the intent to go to medical school. And if you go to medical school, then you're going to be an MD working as a doctor. Not necessarily that you have to work as a doctor, but it's very likely the case that you're going to medical school to work as a doctor. And if you are in the research area, you can probably start to pay a little bit more attention to patent law with some additional training. And this will be beneficial for creating patents for anything along the lines of the research that you've been doing. Next up, we have microbiology. Industry size for microbiologists numbers about 20,000. And this is going to be within the biotech and pharmaceutical industry, as well as some public health sectors. Growth here is projected to be 5%, and this is driven by infectious disease research and food safety. Average salary here is going to be about $82,000 per year. Entry-level roles start around $50,000 per year. Senior microbiologists or industry specialists earn upwards of $100,000 per year. Average unemployment rate is about 3.7%, with microbiology bachelor degree holders, and advanced degrees or graduate degree holders are lower, around 1.5%. Again, the typical education pathway is going to be a bachelor's, which is going to be 4 years. Then the advancement from there is going to be potentially a master's, which would be 2 years, or a PhD, which again is 5 to 7 years. And then there are some additional certifications like the ASCP, medical lab scientists, which can enhance clinical roles or additional work that you can secure with certifications. The typical career trajectory is going to be starting out as a microbiology technician or a lab assistant. Then you can get promoted to a microbiologist or a clinical lab scientist. And then the next promotion would be to a senior researcher or potentially a public health specialist. Some people that get degrees in microbiology like to work in pharmaceuticals, government. Next, we have neuroscience. When it comes to the neuroscience industry, neuroscientists are a subset of biological scientists, with numbers being harder to estimate, but anywhere from 10,000 to 15,000 specialized roles. Broader neuroscience related fields like neurology research employ around 50,000, and growth rate here is projected to be 6%. And this is going to be driven by research in the brain and healthcare. The average salary is about $85,000 per year. Entry-level roles can start around $55,000 per year. And then PhD level researchers or professors earn about $120,000. And neurologists, which are going to be an MD, earn about $250,000 plus. The average unemployment rate is going to be about 3.6% for neuroscience bachelor degree holders, and then PhD or MD holders have a much lower unemployment rate at about 1%. The typical education pathway is a bachelor's in neuroscience. This would take about 4 years, and then PhDs anywhere from 5 to 7 years. And this is going to be targeting research or academic roles. MDs or MD PhDs can be anywhere from 7 to 9 years, especially if you want to be in the clinical roles. So if you're going to medical school, undergraduate research is going to be crucial, but then also undergraduate research is going to be beneficial to help you get your first job at college. The typical career trajectory is going to be something like a research assistant or a lab technician. Then you can be promoted to a neuroscientist. If you get an advanced degree or a graduate degree, then you could potentially become a postdoctoral researcher. And then you can always be a senior researcher, professor, or neurologist if you get the MD. A lot of the neuroscience bachelor degree holders like to enter into biotech or pharmaceutical research and development. Next up, we have genetics. In genetics, the industry size is about 10,000 to 12,000. Again, this is more difficult to estimate due to size. However, this is going to be within biotech and medical research, which is going to employ about 500,000 workers. Growth rate here is projected to be about 6%, and this is going to be driven by personalized medicine and genetic engineering. The average salary for a geneticist is going to be about $82,000 per year, with starting salaries starting around $50,000 per year. Senior geneticists or genetic counselors can earn $90,000 to $120,000 per year. The average unemployment rate is about 3.5% for bachelor degree holders, and then graduate degree holders earn or have a lower rate at 1.5%. Again, this is going to be very typical of all these other degrees. The education pathway is going to be a bachelor's in genetics, or you could get one in biology, which would take about 4 years. Then a master's for genetic counseling, that would take about 2 years. And there's some certification tests that you'll have to take. Or you could go the PhD route, which again would be about 5 to 7 years. And this is going to be focusing more on academic roles. As is with all the biology degrees, lab experience is essential, especially for job placement. The typical career trajectory is going to be something like a lab technician or a genetic counselor. This is, if you have a master's degree, you can be the genetic counselor, and then you can get promoted to a geneticist or a research scientist, and then a senior geneticist or a professor. Many people, again, get a genetics degree to pursue medical school or other roles in the biotech industry, such as CRISPR research. When it comes to the general notes about biology and biomedical science degrees, overall, the life science sector employs about 1.5 million workers, with specific roles about 100 to 150,000. This is going to be in related fields like healthcare, biotech, and pharmaceuticals, and there are always expanding opportunities. Growth rate for these degrees is steady, 5 to 7%, due to advances in medicine and biotech, as well as some environmental research. When it comes to salaries, the bachelor degree holders can earn between $50,000 and $60,000 per year. And then as you get to the median, it's going to be something like $80,000 to $100,000 per year. And advanced degrees get upwards of $100,000 a year to $250,000 per year. When it comes to the average unemployment rate, the average unemployment rate is looking to be about 3.5% to 3.8%. This is just going to be for the basic bachelor degree holders. And the higher you ascend in the field, the more advanced skills you earn, the lower your unemployment rate is going to look like. When it comes to education pathway, again, very standard: bachelor's degree, master's, PhD. Or instead of a PhD, you could go to medical school or dental school or veterinary school, which are going to get you an MD, a DO, or a DVM. And these are going to be pretty much the requirement for clinical or veterinary pass or dental pass. Again, lab experience is important for any applications to the professional schools or job placement. The typical career trajectory is going to be entry-level roles, which is going to be technicians or assistants. Then you can start to specialize into research or clinical positions, and graduate education enables senior roles in academia, industry, or healthcare. Many pursue medical, dental, or veterinary school, as I've mentioned before, and the transition to biotech, pharmaceuticals, or regulatory roles is often common. Think about working with the FDA. Some additional context or trends here. We've got growing demand, and this is going to be focusing on increased treatment that is tailored to individuals. We also have advancements in genetic engineering, which is going to create more opportunities for modifying genetic material to increase health outcomes. And neuroscience is definitely in expanding research industry, which has boosts in research related to the brain and nervous system. We also have, the key employers are going to be medical device companies, pharmaceutical companies, and healthcare laboratories. Increasing roles in data analysis is often common. So if you can take some classes associated with data science, that would be beneficial to secure employment, especially if you want to be a bioinformatics worker. Next up, I'm going to talk a little bit about some of the demographics and data limitations. So biological sciences are diverse, with about 50% of graduates being female, and many students, again, are using this as a stepping stone to professional schools. 40% of biological majors are pursuing medical school. And when it comes to the data limitations here, we've got unemployment rates for niche majors like neuroscience or genetics. They're often an aggregate under biological science. So industry size for specialized fields is small, making precise counts a little bit more challenging. But that is all I've got for biology and biomedical science degrees. What do you think? Are these degrees worth pursuing? Please let me know in the comment section below. And if you've made it this far into the video, you may as well like the video and subscribe to the channel so you don't miss out on future videos just like this one. Until next time.